Hi everybody, welcome to my channel and my Patreon page. So ever you wanted to create something that's not just flashy but also dynamic, well, let me take you on a journey through the most thrilling VEX script you will ever see, hopefully. So here we are diving into a world of explosion, orbiting winds, and creating some web and coming up with this nice effect. So imagine having full control over these wild explosions that burst and fade away like a firework in a perfect scene. Like it's a planet in a space. As you can see, the explosion is like a spider web, appear and spin, and then it fade away, and the explosion, they are swirling because of the wind velocity around the planet. So the scene file will be available on my Patreon page, where you are welcome to be a member. So why you should join my Patreon? Because it's just not about the code and VEX. It's about unleashing the creativity and pushing boundary of what's possible in Houdini, as we try multiple exercises and many examples. So as a Patreon support, you will get access to exclusive HIP files, so you can dive into the project file and explore the intricate setup, so you can dissect and learn from them and apply your concept to your own work. Some of the files and posts have a step-by-step explanation for each code snippet and commentary with why you need to do this and why you need to do that, and with this will give you more stronger and confident arsenal to be a Houdini artist. So every month I'm dropping and adding new content. Like every week I add a couple of new posts, most of them about VEX, Houdini setups, visual effects. So I'm trying always to have a fresh material to play with and learn from. So join the group of passionate creators who, like as you, want to push the limit of what they can do in Houdini, sharing tips, giving feedback, and collaborate with mind-blowing projects. So let's explore the Houdini setup. So in this session, I will guide you through the series of advanced VEX. So we'll explore different functionality, from creating procedural point placement, generating complex geometric pattern, and simulating natural phenomena. And each code will understand what it does and what it do, and how we can creatively implementing it. So at the beginning, we have here a sphere that we added normal to its point attribute, then a rest position, so we can compare the different positioning, and after that we added attribute noise, so we can have some sort of mountain, so it's not a plane sphere or a planet. And from here I scattered one point, so this is the expression that's being changed or seeds every frame. So this is how it will look. And after that I added a solver. Inside the solver I have this code that will remove point after 10 frames. So this is its age. So I can have more than one point every 10 frames. So we have 1, 2, 3 at the same time, but slowly they will fade away and die, and we have new ones. Then I have this VEX code. So this VEX code, it has a start frame and a duration and how many interval that it need to change. So we are generating random points on the surface of the geometry from the second input coming in from the planet or the sphere. The point appear at random positioning on the surface of a primitive, and also they are controlled by several parameters, as we said, like start frame, frame duration, change in the interval. So this setup is ideal for creating effects like a flickering light. So if I highlight it here, so it creates like a flickering light, scattering debris, or any scenario where the point need to appear and disappear dynamically over time. After that we go to the second part where we'll create this effect. So I started with a solver, and in this solver I want to have an interval every 10 frames. So if you look at the detail here in the solver, let me highlight it, just open the detail. So we have the counter, see 10, 20, 30, 40, 50. So we have this interval. This will be reflected as the frame that we will generate the effect. So here, as you can see, this is the code. So this in second part, let me make it run. So in this second part, after the code, I just copy it to the points that we generated here. So we'll have it like this. Let me just phrase it like this. So in the second part of this code, procedurally we generated like a spider web pattern, sort of. So the web consists of several arms that we can control. Here, let me freeze. Here, as you can see, we have several arms that we can play with, and also concentrated ring in the middle, as you can see, and random shapes. So it will generate some sort of attribute like thickness, controlled by randomness, and number of arms, rings controlled that will appear and that will appear then slowly disappear. Also in this script we are nesting a loop to create a point and connect them with a bully line, as you can see here. So this is the bully line. So we have adding more control over the arm thickness, the ring thickness, and the cross line for more detailed and complex web structure. As you can see here in the radius, we can play generating it. So we have multiple shapes. So this technique can be adapted to generate various type of radial symmetrical pattern, sort of. Then, so after I copy it to the points, zoom out, G. So here it is. I added a resample and created a curve view attribute, and then I calculated the velocity. You see, it will calculate the velocity. If I can show it here, velocity. Okay. Then I array it back on the planet itself. As you can see, now it's on the surface of the planet. After that, we go down from our array, we sweep it. So when we sweep, we'll have some polygons, and I activated the scale along curve, so it will be tiny at the end of the curve view. Then I fuse it, so I have less points and less geometry. So next, after the fuse, we will walk through this VEX code where its main function is to control the dynamic density and the particle behavior. So we have some control there. So in this section, we calculate the dynamic density for the particle based on multiple factors. That include the age that we generated previously, the speed, the thickness, and on top of that is dynamically adjusting the particle size or the B-scale attribute, the burn attribute, and the temperature. These will be used in the Pyro solver. So we are controlling the B-scale, the burn, the temperature over time. Okay, so we can simulate an explosion that fade away. This is perfect for creating realistic visual effect where particles start large, as you can see here, large. So they start large and hot because the burn attribute will be high, and then gradually shrink and cool down over time. After that, we rasterize the attributes that we generated, the density, the velocity, the burn, and the temperature, as you can see here. So I have another view. And then we will focus on generating a new like a wind orbit around the planet or the sphere. So in this VEX code, we are simulating a wind that orbit around a sphere, which is resembles the planet, using the cross product between the position and the normal attribute. and we calculate the direction of the wind and apply a rotation matrix here in this code, so we can rotate around the y-axis. So the rotation matrix to make the wind move in a circular pattern around the sphere according to the y-axis. So this setup will control the orbit and the speed and the direction, which will allow for a versatile wind simulation like gusts spiral around an object. And then we calculate the VDB from polygon, and we add the velocity as a displacement velocity vector type. That will be included in the collision in the Pyro solver. So in the Pyro solver, we simulate at point 02. We don't have a ground, but I increase the resizing. The collision is an SDF, surface and the velocity that we generated. We have sourcing for the density, temperature, burn, and velocity, and I make it -1. Let go backward, and we have a field for the density and the flame. We added some turbulence, and the bounce scale I decrease it to 0.1 and no gravity. After that we will have the cache, and in the cache, in the output, we make sure it's converted to VDB 16-bit float, and we are calling the volume, especially the velocity, and resampling it so it will have less volume on the hard disk. After that we apply the Pyro bake volume with a density, with the burn that's converted to flame. The flame will do the intensity, and we have a scatter according to the temperature and the smoke. Next we'll go and talk about the trail. So in this section we will prepare particle to go to the Bob solver. So we start here. So as you remember, these are the web that we generated. So in this section, or this VEX wrangle, or this part, which is designed to initialize a particle with a predefined attributes such as speed, age, scale. So before they enter the Bob solver to create the explosive effect. So we calculate the initial velocity and the scale, and gradually updating their age per frame. So when the particle exceed a certain age, they are removed, deleted. This technique ensures that the particles behave correctly as they transit into the solver, maintaining the intended look of the explosion, as you can see here. Next, we will go to the next VEX code, and in this code we have the first VEX connected to input 0, and the second one is connected to the first input, which is coming from the velocity that we generated over the surface. So in this code we are blending the velocity based on the nearby points, and so we are blending the velocity, the V attribute, according to the second input based on a criteria such as the speed and the direction and the age. So this code dynamically adjusts the blend factor, creating a smooth transition between the different velocities. This is useful, of course, for effect where the particle or the objects need to interact with some fluidity, like a flock of birds changing direction or particle merging into a fluid simulation. But then this matter we are using it to have an immersive explosion. So inside the Bob solver we have the Bob object. We are sourcing from the first input, and the attribute we are decreasing the initial velocity and adding some variance, adding a Bob drag and some Bob attraction, and a force for the noise. After that we cache it, and we add a spark trail. So this is the spark trail where we are splitting and changing the look to increase the intensity by 2, and adding a ramps for the speed, deleting some of the unnecessary attribute and keeping only the one we need, and then we cache it. as you can see here. And after that we have the output for each. This Python will generate all of the attribute, point attribute, primitive, whatever attribute we have on the last node that's connected to, so it will generate it as a reference, so you can look at it close. I'll keep it here if you need it. Inside Solaris we are importing the particle, the Pyro, the sparks, the planet, adding a couple of materials and adding some lights and rendering it through the XPU. So what are you waiting for? Join me on my Patreon and let's make some magic together. One line of code at a time, and an effect and a project. So let's turn the Houdini knowledge that we have into a superpower and create some nice and beautiful effects that we will talk about and share the knowledge about, and make the audience enjoy it everywhere. So thank you very much and have a nice day. Bye.